Hi, good morning everybody. Today now we are going to discuss regarding the properties of ethers. As you know, ethers are colorless liquids, highly volatile. I mean, in a beaker if we keep some ether and after 10-15 minutes we come, थोड़ा घूम फिर के आ जाएगी. In that container there will be no ether left. That means our ethers are highly volatile, just like the study of organic chemistry, which is also highly volatile, as you know. Ethers are having no intermolecular hydrogen bonding with each other. That is why their boiling point, volatility, all these are very. They are highly volatile because molecular force of attraction between either molecule is very less. But ethers can show intermolecular hydrogen bonding with water molecules, so ethers are soluble in water. Now regarding the chemical properties, if we talk, ROR, this functional group oxygen is surrounded by two alkyl groups. So the reactivity of this oxygen decreases. If you are taking ROH, RNH2, RCOOH, like this you are taking, these are terminating functional group. So their reactivity will be very much. Ether are less reactive because of the inertness of this oxygen. Now, when we are talking about the chemical properties of ethers, if you are taking the mineral acids like HCl, HNO3 or H2SO, ethers will combine with these compounds to form, ethers will combine with these mineral acids to form oxonium salts. Now, what are oxonium salts? What are oxonium salts and how are they being formed? This is our ROR and this is our HCl. So this will act as a Bronsted base and it will gain the H plus to form this part is oxonium part and chloride salt will be formed. Similarly, if I am taking here H2SO4, one H plus will be gained by one lone pair to become. What is the name of this? Dialkyl oxonium bisulfate. It can be ethyl, it can be methyl, any ether we can take it here. When we talk about the chemical properties of ethers, the reaction with hydroiodic acid is the most important, and in every examination the question comes on this one. First condition, we are taking less HI and no heating, that means normal conditions. So ROR plus HI, if you imagine like this, we will get ROH plus R. This is not the mechanism, this is the shortcut how I am explaining this. If we are taking diethyl ether, we are getting here ethyl alcohol plus ethyl iodide. In shortcut, I explained this. Hi, one iodine will go with ethyl group and H will go with the oxygen to form the alcohol. Now, in case if both the alkyl groups are different, one is ethyl group and the other one is methyl group, both the alkyl groups are different, then I minus will go with the smaller alkyl group. So we are getting here methyl iodide. This is methoxy group. So number of methoxy group to identify also we can use this reaction. Latter part I will come to that. I am taking this example. Methoxybenzene, or as we say anisole. देखो resonance के कारण there is a partial double bond character here. So the bond that is going to become breaking will be OCS3, OR will be broken here, not the bond between benzene and oxygen here, because there is a partial double bond character. So we are getting here phenol plus methyl iodide. If I am taking this grouping, see this one, or I am taking here this ether, which bond will be broken with the HI? Because this is a primary CH2 group. So iodine will go here and we are getting phenol plus benzyl iodide. What is the mechanism of this reaction? The mechanism of reaction of HI with ethers. Say I am taking HI here. It's a strong acid acetone. We are taking here CS3, CH2, OCS3. As I said in the initial stage, इसे मैंने क्लास के शुरुआत में बताया, it's a Bronsted base, so it will gain, the oxygen will gain the H plus. See this. Now this reaction is proceeding by SN2 mechanism. So the I minus, the nucleophile, they get to neutralize this positive charge. This bond is about to break, and from the remote side this I minus will attack. So we are getting CS3I. Because this bond will be partially, the bond is about to broken, it is not completely broken now. This is the intermediate here. SN2 mechanism it is. That means this is the slow step. Now the next step will be fast. This bond will break to utilize this positive charge. So we are getting ethanol, and this bond between CS3 and I will become very strong now. So we will get methyl iodide. This is the mechanism with the lower alkyl group containing ethers. But if we are having a tertiary alkyl group in the ether, if the ether contains a tertiary alkyl group, then I minus will go with the bulkier tertiary alkyl group through SN1 mechanism. So I am taking this example. Say tertiary butyl methyl ether, and this H plus will be gained by this oxygen. Now the next step will be SN1, means it's a slow step here. Dehydration means removal of this positive charge by breaking this bond between ions. And we are getting methyl alcohol. This is tertiary carbocation, in which I minus will attack this carbon. There can be inversion configuration also. See this. The I minus go with the tertiary alkyl group through SN1 mechanism, because tertiary carbocation is more stable here. Now, my dear children, say this one. If you are having excess HI, and with either we are heating, so ROR, one HI, and this is the second HI. We are getting 2 moles of iodide plus water. The same mechanism, first 1 mole of alcohol and 1 mole of iodide. Then alcohol will react with the second molecule of HI to form iodide and water. The mechanism is of same SN2. I want to explain what is Cecil's method. Without explaining this, either will be incomplete. Number of OCS3 groups means methoxy groups. How many methoxy groups are present in an organic compound? To estimate that, we are using the Cecil's method. I am taking this reaction. There are 2 methoxy groups. So 2 HI will react here. 1 HI here, दूसरा HI here. So we will get 2 moles of methyl iodide. Now this will be reacted with AgNO3. So we will get the precipitate of this one here, this HEI. 2 moles will be precipitated here. So number of methoxy groups. They got 2 AGI is precipitate. और OCS का mass आपको मालूम है 31. The mass, the weight of AGI upon the molecular mass of AGI. We say we can find the number of CS3 groups present in an organic compound, and that is called the Cecil's method. So my dear children, I explained the most important property of ethers, that is reaction with HI. There are so many other reactions of ether, but they are not so important. So thank you, my dear children, for the time being. Let us stop it here. In the next class we will come to the further reactions of